Okay, here's warm-up number 8.4. I've got these three triangles and I want to check if any of the pairs are similar. Maybe all three of them are similar. I don't know, let's see. Okay, so I'm just to make this quicker to refer to them, I'm gonna call these triangles A, B, and C. So let's just check triangle A versus triangle B. So what I want to do is check if the sides are in proportion. Okay, so I'm just going to forget about triangle C for a second. Just looking at these first two. So let's kind of group these. Actually, I'll group all three of them. So I'm going to look for the shortest side in this triangle. I'm going to circle my shortest side. Okay, in this triangle, my shortest side is right here. My shortest side here is the 30. Okay, and then I'll put a box around the medium size side. And let's see, my medium on this triangle is there. Here's my medium, okay? And the leftover piece, I'll just underline that. I just like to kind of group them like that, so that way when I'm checking if the sides are in proportion, I don't get the pieces mixed up, okay? So let's check what I'll call just triangle A versus triangle B. So triangle A, let's try it. Yeah, I'll just write it like this. Triangle A and triangle B. Okay, so let's write proportions. So small sides, 20 and 24. Medium sides are 24 and 30. And my large sides are 26 and 33. Okay, so what I'm asking myself now are those in proportion? So are these three fractions actually equal? So one thing you could do is put them all into a calculator, 20 divided by 24, 24 divided by 30, and so forth, and see if you get the same decimals. I'm just going to reduce them instead, so I can see 4 goes into both of those, so that would give me, if I divide by 4, I'm going to get 5 over 6. Let's see, 2 goes into both of those, so that would be 12 over 15. Actually, 6 goes into both of them, right? So that would, if I divide by 6, 24 divided by 6 is 4, and then 30 divided by 6 is 5. And then I can't reduce 26 33rds. So hey, these are not in proportion. So that's not a pair of similar triangles. So let me check my other combos. There's going to be 3 different combinations. Let's check A versus C then. Okay, so I'm going to make a fraction out of ratio out of my small sides, 20 and 30. I'll try the mediums, 24 and 36. And then I'll try the larges, 26 and 39. Okay, and again I'm going to reduce, so just to make things quick and also to show you just a different way to try this. So 20 divided by 30, that's the same as 2/3, right? It's going to be about 0.66. So I'll just say 0.6 repeating. Let's try 24 over 36. That's also 0.6 repeating. And 26 over 39. Hey, look at that. They're all the same. So those are in proportion, so that is a winning combo, and I'm going to need to write a better similarity statement using their actual names, but this is a winning combo, okay? So the only combo we haven't tried is triangle B and triangle C, so let's give that a shot. Okay, so B and C, my smalls then are the 24 and the 30. Mediums are the 30 and the 36. And the largest are the 33 and 39. Okay, so again, I'll just to make these quick, I'll put them in a calculator as division, 24 divided by 30. And I've got 30 divided by 36. And 33 divided by 39. And you see I'm getting different values out here, right? So these are not, that's not a winning combo. So my only winning combo is A and C, the first and third triangle. So let's write a similarity statement. Okay, so I want to get these matched up in the same order. So I'll just go alphabetical for triangle A. I'll call that triangle LMN. Okay, and that's going to be similar to this third triangle, but I have to get this in the right order. So looking at L, that's between the small and the large sides, right? So between the small and the large sides over here would be the y. So the L and the y are corresponding parts, right? These two angles would be congruent. M comes next. That's between the circled one and the boxed one. So that would match up with the Z. Okay, and then N is between the box and underlined. That's going to be the X. Okay, and there's my similarity statement. Okay. All right, next problem. Okay, are these two triangles similar? If so, explain and write a similarity statement. So I have these angles by vertical angles, and then I want to check if the sides are in proportion. So the smaller side of these two is this one, right? Smaller one here is that one. So I want to check, is 21 to 14 as 30 is to 20. So let's reduce both of those. 7 goes into both of those. That would reduce to 3/2. 10 goes into both of those. Hey, those are in, they are in proportion. So this works for SAS. I've got two sides and an included angle. The sides are in proportion. The angles are congruent. So my answer is going to be yes by SAS similarity postulate. Okay, and that's it for this work, and I'll see you next time.